So hello everyone. So today we are going to discuss about the project which is real-time fraud detection and the narrator. So in this project, I'll tell you the what is the objective of this project. So as we know that the dynamics of like real-time fraud detection. So we have multiple transaction, millions of transaction happening in every minute, and it has to be processed in a real time in order to identify whether it is fraud or not. Why this real time processing is important? Because it is important for the reputation of the bank, and it will also save them to fall into you know into any kind of situation which can so where which they can lose their money, and it will also useful to prevent the customers to fall in such kind of scenario. So so this project is revolving around that objective. So we have to achieve this, we are using the concept of Kafka for real-time data processing. And in the Kafka we have a concept like producer consuming Kafka topic, which we will discuss later in this video. And I'm also using the functionalities of Python like pandas, numpy, and I'm using some like rules based fraud detection engine to score my transaction uh, in a such a manner that for each transaction I can get a score. So if that particular score is greater than the threshold, then that particular transaction will be counted as fraud, and if it is not, then it will be counted as valid transaction. And the second part of this, so so once the data is tagged as fraud or not, so what happens that these rules are decided a way back when the bank decide or bank started facing some kind of fraud in a frequent manner. So they have reached on some uh, they sit together and they decided that if this happen, if the transaction amount is a little high, then we'll count it as fraud. If the number of the declined transaction are multiple, we have declined transaction, then we will count it that transaction as fraud. So but the dynamics of fraud and the type of fraud is changing on a day by day. So we are also using the GenAI to tell us that the whatever the decision my rule based engine is made, justify that whether it is fraud or not. So we have a decision that it is that one particular transaction is fraud. So now I'm using the LLM and GenAI functionality to narrate that why this particular decision is made. So this is the overall objective of this project. So I will first give you the some glance of Kafka. Let's just wait a minute. So this is Kafka. So in Kafka, basically I'm using Confluent, which is the managed version of Kafka. So what it is doing, so as we know that multiple transaction is happening in every minute, right? So we have some functionality in a real time which can hold that transaction load somewhere, and we can from that load we can pick transaction one by one or multiple transaction at a time, and we can apply some logic and we can tag those transactions whether they are a fraud or valid transaction. To achieve this, I'm using uh, this Kafka like concept of Kafka. In this Kafka we have a producer and consumer. So once we receive the transaction or list of transaction, so what producer will do? Producer will produce these number of transaction into the Kafka topic. So Kafka topic, it looks like a table, but it is not the real table. So which will hold the transaction detail in that particular topic, and it will wait until the that particular transaction is consumed by the consumer. So once it is consumed by the consumer, so it depends on the developer. So what he want to do with that consume transaction, he can save that transaction into the like any database like SQL, NoSQL, or graph based data set, or he can do some transformation, or he can apply some logic. So our objective is, so from the consume transaction we have to identify where this consume transaction is fraud or not. So here we are using the GenAI concept. Okay, so it is clear. So we are receiving the data from the user. So producer is producing this data into the Kafka topic, and consumer is consuming this data from Kafka topic. So on the consumed data, we'll apply some logic to identify the nature of the transaction. Correct? I think that is clear for everyone. So this is how the Kafka topic look like. Okay, so I created one Kafka topic here, transaction table, where I will save, or where for a moment I'll save all the transaction into this particular Kafka topic, and it will be here until it is consumed by the consumer. So now I'll show you my code. So this is, I'm mimicking the transaction. So I'm creating, so like, so in any transaction, these are the main field: account ID, transaction amount, transaction frequency, historical transaction frequency, transaction time, decline transaction in foreign country. So these are the fields, so which I'm creating with the help of pandas and numpy. Okay, and I'm saving that file into my local system. And after the produce the like transaction started happening, so now producer come into the picture. So let me run the code for producer. Okay, and meanwhile I'll show you how this code is working. So as I show you that uh, I'm using the concept of Kafka, so I'm making the configuration between that Confluent Kafka, and I'm like from the schema registry I'm identifying the type of fields, like what are the data type of that field. And now I am using so yeah, I and with the help of our properties I have created my producer. And with now I am what I'm doing, so whatever the data is getting generated from this file, it will be consumed from the consumed by the producer. In which topic? In sorry, in the transaction table, this data will be consumed. And how the data will be look like, if you see account ID, this, and if you see record t, okay, t 2014 is successfully produced. And let me show you, if you see the number of transaction will increase. So now we have 408 messages, so 408 transaction has been happened. So if I refresh this, uh, it is taking some time. So now 422 message has been produced, means 422 transaction has been happened. So like, and how it is getting produced, it is getting produced by the producer, which is saving this data in this particular topic. Okay, now the part of consumer comes into the picture. So let me start consumer as well. Okay, so consumer, let me show you the code of consumer. So this is nothing, this is the configuration. And the where, like here I am subscribing that particular Kafka topic from where I have to consume the data. And it is infinite loop. And for like before reading the data or consuming the data, it will wait for like some for some time, and it will start reading some data. and and like once the data is consumed, it will apply some logic, which is fraud detect logic. So for fraud detect I'm using this rule based engine. So here, if you will see, we are scoring the transaction on the basis of like a category. If the transaction amount is greater than 5,000, we will assign it some score, and like similarly on the basis of transaction country decline transaction, we will assign some score, and we have decided some threshold value. If that score for that transaction is greater than the threshold fraud score, then we'll saying that this is fraud. So once we have got this score, I am calling this particular function. Explain me why this is fraud. So narrate me why you tagged this as a fraud. Okay. So this particular function will take two argument: transaction and the rule which is coming from this function, rule based fraud. So I have like written a template in a such a way, a prompt in a such a way that it is I am assigning a responsibility to a LLM model that you are a fraud detector, and I have raised on a particular decision. Now you have to justify why this decision is made. So it will take two argument, like decision I have made and the transaction text. So I'll tell you one more thing. So in order to use LLM, I'm using the Llama. So since OpenAI is coming with some API key, so I try to avoid that API key. So if you lose that, you can be billed and you have to pay some amount. So I'm using the Llama, and I'm creating a chain of this with the help of LangChain. So the GenAI part I am covering with the LangChain. So LangChain is kind of framework which will give you the functionality of using so many LLM things with the, and it will also give you functionality of RAG, and you can also create chains of prompt agents and LLM. And now here I'm creating the chain of my prompt and the LLM, which is Llama. Now I'm invoking this chain with the two argument, transaction text and the rule I have decide the rule decision whether it is fraud or not. So it will analyze this transaction based on this prompt, and it will give us some output on a dashboard. So I'll tell you how that dashboard look like. So for this particular transaction, this is tagged as fraud, and why it is tagged as fraud, so we have a description as well. So based on the transaction detail, that the decision is to flag this as fraud makes sense because it exhibits a high transaction amount, uh, and the frequency of the transaction is relatively high than the average frequency, which are unusual pattern for this account. Additionally, the fact that this is not the first instance of the decline transaction, like it also have a multiple decline transaction for this particular transaction. That's why my LLM is saying this particular transaction is fraud. So, and this I made with the help of Streamlit. So once again, I will try to wrap up everything. So we will get so many transactions from the users. It will be so Kafka will come into the picture, which will produce these transactions into the Kafka topic, and consumer will consume these transactions from the Kafka topic and apply my rule-based engine and GenAI logic on top of that. And after that, once everything is done, it will uh, like redirect me on this dashboard, where for each transaction I will get to know how many fraud transaction are there and why they are tagged as a fraud. So yeah, this is all about this real-time fraud detection dashboard. So thank you so much and have a good day.